Find the open intervals where the function is increasing and decreasing. Given a function f of x equals to 2x cubed plus 3x squared minus 12x plus 4. Begin with finding the derivative of the function. F prime of x equals to 6x squared plus 6x minus 12. Taking 6 as a common factor, we can write f prime of x equals to 6 times x squared plus x minus 2, which equals 6 times x plus 2 times x minus 1. Next, find the critical points by setting the first derivative equals to 0. F prime of x is 6 times x plus 2 times x minus 1. By setting this equals to 0, we get x equals to negative 2 and x equals to 1. These form the critical points. Observe there are no points where the function is not differentiable. Use a sign diagram to find the intervals where the derivative is positive, negative, or equal to 0. Use the critical point we obtained to divide the number line into open intervals, as shown here. The critical points we obtained are negative 2 and 1. Use these critical points to divide the number line into open intervals and pick test points in each one of these intervals: negative 3, 0, and 2. Find the sign of the derivative at each one of these test points, as shown here. F prime of negative 3 equals 6 times negative 3 plus 2 times negative 3 minus 1, which is a number greater than 0, meaning the function is increasing in the interval containing the test point negative 3. Find the sign of the first derivative at the test point 0. F prime of 0 equals to 6 times 0 plus 2 times 0 minus 1, which is a negative number indicated by negative sign in the interval containing 0. Similarly, find the sign of the derivative at the test point 2. F prime of 2 equals to 6 times 2 plus 2 times 2 minus 1, which is a positive number, which means the function is increasing in this interval containing the test point 2. The function is increasing in the open interval negative infinity to negative 2 and the open interval 1 to infinity, and it's decreasing on the open interval negative 2 to 1. Find the critical points and find the intervals of increase and decrease of the function f of x equals to x squared minus 6x plus 5. Find the derivative of the given function. F prime of x equals to 2x minus 6. Taking 2 as a common factor, we can write f prime of x equals to 2 times x minus 3. Set the derivative equals to 0 to find the critical points, which means 2 times x minus 3 equals to 0, which gives x equals to 3. X equals to 3 is the critical point. Use the critical points we obtained to divide the number line into intervals, as shown here, and pick test points on either side of the critical point. We want to find the sign of the derivative at each one of these test points. F prime of 0 is equal to 2 times 0 minus 6, which is a number less than 0, which means the function is decreasing in this interval. Similarly, f prime of 4 is 2 times 4 minus 6, which is a positive number, which means the function is increasing in this interval containing the test point 4. The given function is decreasing on the interval negative infinity up to 3, including 3, and increasing on the interval including 3 to infinity. Since the function is continuous and there is no interval in which the function is constant, we can include the point 3 in the interval.